Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, we're going to be doing a Monte Carlo analysis. Monte Carlo is an alternative type in ResSim. It's used to analyze a output results from a simulation when certain input variables are uncertain. Okay, what we're going to do here is sketch out a reservoir, run a simulation, and then answer a specific question. So what I'm going to do, here's the question that I'm aiming towards, and it's this. How many gates are needed in the controlled outlet of the dam to prevent the water surface elevation from exceeding 1,485 feet 85% of the time, and to prevent the water surface elevation from exceeding 1,490 feet 95% of the time? During the month of January 2024 is going to be our simulation duration. Clearly, from that problem statement alone, we don't have enough information because I need to build the network and add all the other variables. So we'll be returning to that problem statement, but for now, we first need to build out the watershed, the network, and then run a base case. All right, video 36 is what we're on here. Go ahead and create a watershed. So give it a name and then select that watershed location. And then specify the units and the time zone. And then go ahead and click OK. And that will create our watershed. So let's zoom in here. I'm going to select the stream alignment tool here on the left tools menu. Hold down Control and then single left click to sketch out a stream alignment. I'm holding down Control the whole time until my final click, in which case I let go, and then one last click, and then ResSim prompts me for the name of that stream. I'll just call it Stream 1. Okay, and then I'm going to select the computation point down here, and then hold down Control, single left click, CP1. I'm going to use that for my inflows, and then I'm going to select the reservoir tool here on the left, hold down Control, single left click on the upstream end, let go of Control, click on the downstream or the downstream, same thing, and reservoir 1 is what I'll call it. All right, let's add one final computation point down here at downstream end of the reservoir. All right, that looks good. I'm going to go ahead and go watershed configuration editor. Go configuration new, config 1. I'll just, yeah, 1 hour is fine. And then save the configuration, save the watershed, and we're ready to make edits to the reservoir. So I'll go to the reservoir network module here in the module drop down. This is where we make edits. Okay, first thing I'm going to do is go network new and create a network. So I will call it network 1. It will be the only network, and that'll be based on config 1. So make sure to select your configuration that we just saved there. And okay, we're looking good. I'm going to go ahead and connect the network here by selecting the reach tool in the left tools menu, hold down Control on the upstream junction, then let go of Control, and then just click on the next downstream junction. Okay, you can give it a whatever name you want, but do that for the downstream reach as well. And we're in business. Okay, so next, let's go ahead and add that inflow to the upstream junction, which is CP1. So I'm going to click on this local flow tab, and then I'll just call it inflow at CP1 with a factor of 1 over here. Apply. Okay. Next, I'm going to make some edits to the reservoir here. So I'll select the reservoir tool and then right click on the reservoir, edit reservoir properties. First, the pool geometry. Okay, I'm going to paste the pool geometry in right here. So our total storage is 100,000 acre feet, and that's at a top elevation of 1,500. Over at the dam, I'm just going to type in 1,500 here, and then I'll make up a dam length. I'm going to add a controlled outlet to the dam face, as I alluded to in that problem statement I read earlier. Here's the controlled outlet, and then here is the controlled outlet max capacity versus elevation for each gate. So we'll just leave it at 1 gate for now. Now I'll click apply. And then over in the operations tab, this is where we need to set up our zones. So I'll go operations new, operations set 1, and then okay. All right, here are our zones. I'm going to just type in some zones. Top of zone elevations of 1,500 for the flood control zone, be 1,480 for the conservation zone. and then inactive will be a top of 1400, which is also the invert of the outlet. That looks good. I'm not going to include any reservoir rules, not right now. I'm just going to let the releases dictate based on capacity and everything else. I'm going to go ahead and click OK. Next, I need to specify a inflow for this CP1 junction, and I will do so by creating a time series dataset here in DSS view. So first of all, I'll go File, New, and this is my watershed directory. So I'll create a DSS file as my first step. I'll call it time series data.dss. The file's been created. And then next, I'm going to go up to data entry, manual time series. And then here I'll type in project location flow CP1. The start date will be January. This is for the month of January 2024. So we'll say 01 Jan 2024, the first hour, then the units will be CFS, instantaneous value. Okay, great. I have the values on my clipboard, so I'm just going to select this first cell here, this first hour, and then click paste. And then those values paste in there. I'll hit save, and then I'll show you what that looks like here. Here is that inflow. So this is hourly flows, and it starts at about 1,000 or maybe 1,500. After about 5 days, it peaks at around 11,000, and then it goes back down with another smaller peak towards the end of the month. So that's just one time series. I'm going to use this for the first alternative, which will just be a standard alternative, and then we'll get to the Monte Carlo alternative and start to do some analysis. Right, so I'm just going to leave that there. Now I am able to create my alternative, and because I needed that inflow data. Okay, so I'm going to go alternative, new. I'm just going to call this base for a base case, like a standard type. So I'll leave this standard alternative type selected, and then I'll go with the 1 hour time step, and I'll leave the other parameters the same. The operation set will be operation set 1. The water surface elevation and the look back for the reservoir pool will be 1480 because that's the guide curve elevation. I'll just say 1000 for a release during the look back period. Again, this is just for 1 hour, so it's not too significant. And then time series is the last part I need to specify here. And I'm going to select my inflow at CP1 record and then click select DSS path, navigate to my time series data.dss file, select the record that we just created, and then click set path name. Okay, clicking that set path name button made the reference over here to my alternative. And now I'm going to say save. All right, I'm going to go ahead and save the network. And then we can switch over to the simulation module. Here I'm going to go simulation, new, simulation 1. And then again, this is for the month of January 2024. So yeah, to keep that in mind. And then the time, I'm going to start the simulation on the second hour. And then I will start the look back period on the first hour. And then the simulation will end on the final hour of the month. Okay, and then I'm going to select this checkbox here for the alternative, and okay. So our simulation is ready to go. We have our simulation in the simulation tree as well as our alternative. And here is our image of the network. All right, so I'm going to go ahead and run this and just see what it looks like first. Nothing special. This is not Monte Carlo analysis yet. I'm going to plot. And what we see here in the top is the water surface elevation rising well above the dam. And that's what I wanted to see, because there's only one gate. And what we're going to want to do is increase the number of gates, but we're also going to vary the number, the inflows as well. That's where the need for the Monte Carlo type alternative is going to kick in. So just to show you what I was talking about at the bottom here, here are our inflows. And then this green line here is the outflow, and we're just maxing out because there's only one gate. If we take a look at that, the capacity again, it's not much. Here's the controlled outlet, and we can only release 1100 CFS. So that's not nearly enough when our inflows are 1100 or 11,000 CFS. All right, so that's good for a base case. We kind of know what we're dealing with here. Next, what I'm going to do is create a trial, and all the trials are going to be for the Monte Carlo simulation. So just as a reminder, I'll go ahead and say MC. And then how many gates should we start with is a good question, because it's going to be more than one. It's probably going to be more than two and three. What if we just started at 4 gates and see what happens? Okay, so I'm going to just call it 4 gates. Obviously, I have to make that edit as well. So I'm going to right click, edit, run. We are making edits here. So reservoir, I'm going to go controlled outlet and then change this 1 to a 4. Okay, and apply. Okay. Now what I want to do is make some changes to this alternative editor. So of course, this is where we need to change the alternative type to Monte Carlo. And then in the Monte Carlo tab up here, we have to add the input variables, the output variables, and then specify the Monte Carlo controls that are just settings for the simulation itself. The input variable, I'm going to modify the inflows. Now, we already had that one inflow saved, but I have a number of other January 2024 inflows that I'm going to use. So that's going to be input time series here. This is the first of 4 steps in the random variable wizard. So I'll select input time series and then next. And then the inflow at CP1, this is the only time series to select. So that's good. That's correct. Next. This is the only option on the reference dependency. On time dependency, I'm going to stick with constant distribution parameters, not anything seasonal. It's only for the month of January anyway. Okay. And then now what we're going to do is specify different inflow time series as well as the weights. So ResSim can use that during the Monte Carlo compute. Okay, I've opened up DSS View and I've navigated to my different inflows for January 2024. I've got them highlighted on the screen here. And if we bring them up, we can see here they are. They are 1, 2, 3, 4, 5 separate series, one of which is the one we just saw, and then 4 others as well. So I'm not going to look at the numbers, but it's similar to what the first one was. And what I want to do first is copy these records into the simulation directory that we've already created. Therefore, referencing them inside the Monte Carlo tab, inside the alternative editor, will be much easier. Just from experience, that's worked best for me. So I'm going to go edit and then copy to. Now I'm going to navigate to my watershed directory first, which was in exercises, video 36. And then it's in the RSS directory. And then here's simulation 1. This is the name of the simulation. And then the DSS file I want is simulation.dss. So I'm going to go ahead and click open. But what I'm really doing is copying. So I think it's going to tell me 5 files are successfully copied. Okay, 5 records copied. That's good. Okay, so I'm going to minimize that. Now, I'm going to go ahead and make those assignments. So let's select the first record here and then click this Select DSS Path button. Okay, so let's navigate to that DSS file that we moved our 5 records to. And simulation.dss is it. Open. Okay. And where are they're down here. So I can actually find them faster by filtering, I think. How about just American? Okay, here they are. So using the filter, I got them on screen. It's 2002, 3, 4, 5, and 8. I'm going to select, let's see. So I got the first record selected, and when I click Set Path Name button down here, then, okay, cool, that worked. And then I'm selecting the second one, and Set Path Name, third one, Set Path Name, fourth, set path name, last one here, and set path name. Okay, so I can get that out of the way. Now I need to specify the weight. So I'm just going to give them equal weight. So I'll just type the same number in here. And the math is, probability is calculated. So it's 20% for each of them. If I wanted one to be more heavily weighted, I could just type in a bigger number like 7. And now that one is much more likely to be used in the random generator. But I'm not going to do that, just showing you how it works. All right, so that's ready to go. I'm going to go ahead and hit finish. That's all I need to do for input variables, but I still need to do output variables and Monte Carlo controls. All right, so output variables. Add. Now I'm interested in the water surface elevation of the reservoir pool. That's this one here. So I'll click next. Now on this, I'm interested in the maximum, so I'll keep that there. Flag, I'm not going to use that, but convergence, I do want to specify convergence to, we'll say within 1% of tolerance. And if it doesn't converge, I will loosen up that number, but I think 1% would work. All right. Looking back at our problem statement, I'm interested in 1485 and 1490 feet elevation with regard to the iterations that exceed that particular elevation. So the non-exceedance of 1485 must be 85% or more, and then the non-exceedance at 1490 must be 95% or more. So basically, I have two conditions. The reason I'm bringing that up is 1485 and 1490 are the two elevations that I'm curious about. So I'm going to type those in here, my values of interest, and then those will show up on the output report. So we'll see these numbers a little bit later. Okay, finish. Next, the MC controls, the Monte Carlo simulation controls here. 100. Let's go ahead and pump that up to 300, just so we have a little bit more data to use. And then let's see, not going to need 1,000 most likely. Not going to use a seed. I think, hold on, if I just hover over this, it says, okay, if the seed is left empty, random number sequences will be inconsistent between alternatives and simulations. That's fine. That's actually kind of what I want. So I'm going to go ahead and just delete that so it's empty. And then I'm also going to select this second option here because each time I run this, it's going to be new results. I'm going to have changed the number of gates is actually what is sort of my decision variable that I'm trying to figure out the final answer for. All right, I think we're good. So again, this is the 4-gate scenario, which may be undersized. It may be too many or too less. We'll find out based on our results. Okay, so that's ready to go, and let's run it. Okay, so it's running through the iterations. Sorry, we're going up to 300. We're going up to 300, and finger crossed, there it goes. Okay. So cool. So it converged, and let's take a look at the report. I'm going to go reports, Monte Carlo, base 1, representing 4 gates, and then output report. Now, if I scroll down to the bottom, what I'm curious about is, okay, that's not even close. Is these two values here, 1485 and then 1490. And this is the non-exceedance probability. So 14.5 basically means only 14.5% of the time was a water surface of elevation of 1485 not exceeded. So that's kind of the opposite of what I'm looking for. I want this number to be 85% or more, and I want this number to be 95% or more. Now, it's good that they were in the right direction. This number should always be at least as big as this number, and this is a percentage. But clearly, 4 gates is not enough. And I think since this number is so small, I want to say 5 gates is also probably not enough. So let's go ahead and create another trial and then see what we get. All right, so back to our simulation tree. I'm going to go new trial, and I'm making a trial based on the trial we just created, just to save us all the time and headache and hassle with regard to setting up the Monte Carlo alternative data. So I don't need to do any of that again. That's why I didn't make a copy based on the base, which was just our standard alternative. So yeah, so I'm gonna give this trial a name. It's gonna be MC is 6 gates. Let's see what six gates does for us. All right, so I'm gonna go ahead and make an edit. The only edit I need to make, thankfully, is changing the number of gates. So let's go change that 4 to a 6, and then apply. Okay, okay, and then let's run the compute for for up to 6 gates now. Again, we're counting up to 300 on the iterations. We're up to 100 right now. All right. So that's complete. Let's go ahead and take a look at the results. Report Monte Carlo. Again, this is now the second trial, base 2, representing 6 gates. And the output report, gonna scroll down to the bottom, we should see some higher numbers here. So 79.17 and 79.17. Okay, so clearly closer. We've almost achieved the 85% here at the 1485 elevation here, but still a ways to go. I feel like 1, maybe 2 more gates might do the trick because that was a big improvement over 4 gates. Let's go ahead and make it 7 gates and see what it looks like. Okay, so I'm going to right click, new trial. This one's going to be MC 7 gates. Okay. I mean, even if 8 gates was enough, we'd still have to check 7 gates to make sure that didn't also satisfy. So I don't think it's too big a deal just going up 1 like this. All right, edit, and then reservoirs, the outlet, changing the 6 to a 7, apply, okay. Okay, and run. So that computed and we're done. Let's go ahead and look at the report Monte Carlo onto the third trial now and output. What do we have? Okay, 79.2 still and 100% convergence or non-exceedance at 1490. So finally we have one of our two cases has been satisfied. That's the 1490. But 1485 we still have about 21% over that 1480 foot elevation mark. So I think 8 gates will be enough, but just for good measure, let's go ahead and create that final 8-gate trial. Right click, edit trial, name our new trial, or create new trial, 8 gates. Okay. So nice to only have to change one thing. Reservoirs, controlled outlet, 8 gates, please. Apply. Okay. And then let's compute. All right, that computed in 19 seconds. Not bad. And let's go ahead and look at the good news here. Output report. And we have 100%. So that's great. That means there is zero exceedance probability for both 1485 and obviously 1490 as well, foot elevation, when we have 8 gates in the controlled outlet. What I have on the screen here is a quick summary of what we did. Our first trial was 4 gates and then 6, 7, and 8 gates. And at 1485 and 1495, water surface elevation, we had these different non-exceedance probabilities reported. So it wasn't until our fourth and final trial with 8 gates was this number under 85% and above 85%, and this one above 95%, which I don't have listed here, but those were the requirements that the two requirements that I mentioned in this problem statement here. Looking back at the report, I just want to make some final comments, and it's this. First of all, here is the quartile for the water surface elevation. So one quantile, 2.5, 5. We have 50%. And then what you notice is that there's only 5 values here. And so here's one value. Here's a second, a third, fourth, and then a fifth. And I believe that it's only using the 5 inflows that I provided, which really isn't as realistic as we could make it. But that's what I told ResSim to do. And it's also a good first exercise to kind of understand how this particular option in the Monte Carlo alternative type works. Okay, so I'm going to close that report, and I also want to bring up the simulation. So this is the simulation data here. And if I scroll down, what I'm seeing here is there are data sets for the realization choice and then the realization probability. So for the first trial, which is this one here, if we open up, say, the table data, ResSim's coming up with this random number generator here, 0.51417, 0.06744. And then based on that number, it's selecting 0 through 4, like basically one of the 5 inflows. So a higher number like 0.87, it selected the last one. And then for a small number like 0.06, it selected the first one. And then it's just running these, picking one of those 5 based on the weights and hence probability that I assigned it. And yeah, again, with this much discretization and the randomness, we can certainly create a more realistic set of inflows to use to solve a problem like this. But it's all good. This is just part of the learning process. So I'm back in the alternative editor, and I just wanted to point out that Monte Carlo tab, of course, input variables is what I meant to type. And then if I click edit, keep in mind that our edit option here was this input time series, but there are different ways to also provide input to ResSim in a different way that would also be able to bring out more rich results and more meaningful results than what we saw in this exercise of just randomly selecting one of the 5 inflows that I told it to choose from. All right, so that was it for this exercise using the Monte Carlo type alternative in HEC ResSim.